So we are at the Heletz CO2 injection site. Now it's the day of commissioning of the injection system, and Jacques Bensabat, who is the project leader of this Heletz project, will introduce or explain to us the equipment that is here on the site now. So maybe we can go in order from... Yeah. Maybe you can say something first about how the project initiated.
We are here in Heletz, the site of a depleted oil field. In this area, the target layer is about 1650 meters, and it is called the Heletz sands. They were exploring for oil here, but they never found oil. They found only brine, so it was an ideal site for CO2 injection experiments. Here we have installed a number of facilities that can be divided into 4 groups, or 3 groups I would say. We have wells, injection well that you see here, and monitoring well that you see about 50 meters from here. We have above the ground facilities for conditioning the CO2, which are on that side. We will go in greater detail later on, and we have also a control room for monitoring and analysis. So if we can start with the injection well, this is a typical oil well at a depth of 650 meters. Installed facilities include pressure and temperature sensors, online measurement, pressure transmitting, an optical fiber for continuous temperature sensing, and a tubing tube for downhole high pressure fluid sampling. In addition to that, what you see here is the connection to what is called a chemical injection line, a line that connects to the main tube for the injection of impurities, tracers, or CO2 for saturation purposes. What you see here is the Christmas tree of the well, which stands pressures of up to 5,000 psi, or about 300 atmospheres, about 340 atmospheres, and this is for safety purposes. That blue line here is a high pressure air line that allows water abstraction or fluid abstraction via airlift. We have pressure and temperature sensors in the critical path of the piping, so we have all the time online in the control room the complete information and control of what is going on. Now in that what we have here is a CO2 tank, an installed CO2 tank with the capacity of 22 tons. It can deliver up to 4 tons per hour. The skid is quite a complex system that includes a booster pump and 2 pumps, a low flow pump and a high flow pump, and I will explain what is the purpose of these pumps. Basically the CO2 gets into the system here, and it will encounter first a booster pump that is aimed to increase the pressure of the CO2. The pressure of the CO2 in the tank is 20 bars and the temperature minus 20 degrees Celsius. So it is in liquid conditions, and we want to keep it this way. So this is why the first thing that we do is that we increase the pressure of the CO2 in the system. So then we make sure that it is liquid, because if it becomes gas, then the system may not work as well. Once it gets the pressure, the CO2 will either be flowed into the high flow pump that has a capacity of up to 4 tons per hour, or the low flow pump that is here that has a capacity of up to 250 kilos per hour. Now, the purpose of the high flow pump is obvious. It is for injecting CO2 into the formation. the purpose of the low flow pump is for saturating water to be injected into the formation with CO2. So, and all the devices that you see here that we cannot go into details are safety devices aimed at controlling the pressure of the CO2 and preventing leaks or preventing the impact of leaks if something happens. Once the CO2 has got its pressure, that is design pressure and discharge, it is flowed through that pipe that you see here into a heat exchanger that is fueled with natural gas, or with not natural gas, it's fueled with gas, and you see the storage tanks of gas just nearby. Now the CO2 is then flowed and we can determine the target temperature. So we have flexibility in if we want to inject cold CO2 or high CO2, and as I said, natural gas. We have a possibility also to bypass the heating by just directly flowing the CO2 through that pipe into the system. What you see here is a batch reservoir for injecting batch tracers. So if we want to inject tracers in batch mode, the only thing that we have to do is to open that valve here that will also flow the CO2 not only in the main line but also in the batch reservoir line. That manifold here is relatively complex. It has a number of components that I'll displayed now. This is the main line of supply of the CO2. If that valve is closed, and that valve is closed, and that valve is closed, the CO2 will flow directly through that pipe to the well and the injection. We have a control of pressure and temperature, as you see here. We know the pressure and the temperature of the CO2 at the wellhead, and we know also the pressure and temperature of the CO2 downhole. This way we can absolutely predict the state of the CO2 in the injection tube. Returning here, that small system here allows to inject CO2 at low rate for the purpose of saturation. When we do that, we connect a pipe, a stainless steel pipe, from that port to that line, and then we can inject the CO2 at a depth of 1,000 meters, in the same time being able to inject also water into the main tube. In that way, at 1,000 meters, we can mix the CO2 and the water with a pressure that is high enough so it is representative of the formation conditions.